When graphing rational expressions, it's important to know if you have a vertical or horizontal asymptote. This will help guide you into graphing the problem. Vertical asymptotes are very easy to find. 0 can never be the combined total in a denominator. So if you use the number 2 right here, 2 minus 2 would make 0. So you can see that 2 is a restriction because you can't have 0 in the denominator, and that number happens to be what's called your vertical asymptote, a line that is never ever crossed. Now, your horizontal asymptote is a special case scenario. It's based off of the total degree in your rational expression. So this has a variable with a power of 1. Therefore, it's called degree of 1. This has no variable, so no degree. Because this is bigger than this, that means you're going to have a horizontal asymptote. Your horizontal asymptote is always going to be the whole number that is attached to your rational function, so -2. So at -2, we now get a graph, a horizontal asymptote, and this helps guide the equation. So now you can see that you have this vertical asymptote, this horizontal asymptote. Now to find the rest of the graph, what you're going to do is you're going to use tables just like you have before. You're going to set up an input and output system. Now I recommend you set inputs on the left of the red dotted line and on the right of the red dotted line. So you're basically going to have two sets of inputs and outputs. The numbers I would use, small numbers are fine. Closest numbers to this red vertical asymptote are typically better. So the numbers 3, 4, 5, those are really close to this. On the other side, we've got the numbers -1, 0, 1. And then from there, it's one calculation at a time. Literally, you're substituting in, let's take 3. When you put 3 into the function -1 over x minus 2, what you're doing is you're taking this x and making it a 3 minus 2. So you're doing two operations here. The first operation is simplifying this rational expression. So 3 minus 2 is 1 over -1 minus 2, which is the same thing as -1 minus 2, which is the same thing as -3. So when you use 3, you get -3. Therefore, you got 3, -3 right there. And so you're going to keep doing this, one input and output at a time. I'm just going to go through these. You can check your work by doing it by yourself, so you can pause the video to see if you can do the rest of these without my assistance. But if you put in 4, you should get -2.5. If you plug in 5, you should get -2 1/3. If you plug in -1, no, let's actually do +1. If you do +1, what you're going to do is you're going to get -1. If you plug in 0, you're going to get -1.5. And if you plug in -1, you're going to get -1 1/3. All these points, one would be right here. There is the coordinate 4, 2.5 down, 5, 2 1/3 down. Over here, 1, -1, 0, 1.5, -1, -1, 2/3. Sorry about that. And by definition, once you connect these are going to get really close to your asymptotes, but never touch them. And that's how you graph this rational expression.